So today we have a CTC2 chassis, which came out of a RCA CT100 running on the test jig here. The colors aren't exactly right because I have a little work to do on the red circuit, but we're here to talk about the power supply. Now, on the power supply on this, one of the Achilles heels was this ballast tube. It's not really a tube, it's just two resistors and a plug-in ballast. And we've all seen it. It looks like this, and it's not very stable, and it doesn't provide any regulation at all. And it's what happens out over time is if they burn out and open up, and they're just not very good. And we make all kinds of replacements for those with resistors and things like that. But what we have here is a replacement that was built by Mr. David Negaard when he was employed by RCA at Princeton in the late 1950s to work as a replacement for the plug-in ballast. So what it is two 6AS7s or 6080s with two 6AU6s and a 5651 gas tube. So here's the circuit here, and I'm going to post it up. I'll do a scan and post it. The gas tube acts like a zener. It clamps the two 6AU6 cathodes, and you can control the current through the two 6AU6s, which control the grid on the 6080s. Therefore controlling the current through the 6080s, and it creates a voltage divider. These are the pins that would normally be on the ballast tube, which I indicate here. So what you would do is you're going to convert your plug on your ballast tube to coincide with these pins. You'll have to make a few changes. Pin 4 and 6, which on here 4 and 6, and I'm sorry about my photography, 4 and 6 have to be, you just lift them off and connect a filament transformer AC to that, and take 4 and 6 and connect them together. And that's really all you have to do. And then you're going to ground number 8 on the chassis. So you're going to add the filament transformer. So here's the circuit here. And there's nothing reactive about this. It's all resistive. And it's done by controlling the current on these tubes. And by controlling the current, you're actually controlling the conductance on these tubes. We're able to hold these voltages very close. I have 2 meters on here. I have one on the number 2 285 and the number 3 285. So no matter what the input is, these voltages stay very close. And you can see when I adjust here, I can adjust this 285. Get it close. Or I could adjust this 285, the other one here. So for whatever the input is on the 400 side, you're going to get rock solid regulation. So there it is. It's built they did a very nice job of building this, and I'll take some photos underneath and post them. And on the diagram here, I have the part numbers for everything that you would need to do it, and the pin out. And we have to thank Mr. Negaard, who's still alive. He's 88 years old, for coming up with this. And if anybody that has worked on a TM-21 RCA studio monitor would recognize this is a variant of the voltage regulator that's used in that set. So there you have it. Something to make the CTC2. You can use this on a 21 CT55 as well. In fact, I did a previous video showing a 21 CT55 with this circuit built into the power supply. So there you have it. Got to make a few modifications over here. I just have it jumped in to make sure it's going to work. So I'll have this circuit posted. And anybody that's interested, want to make their CTC2 work a little better, this is the way to go. Thank you, David Negaard.